Assalamu alaikum. Today we will study section 2.2, but let me first review with you what we learned in section 2.1. That section was about the quadratic function. We did learn in that section how to solve the quadratic equation using factors or formula. We did learn also how to sketch the graph of the quadratic function. So as an application on that topic, we will learn today this section, which is about revenue, cost, and profit. So the objectives of this lesson are, at the end of this section, you should be able to express the total cost, express the total revenue, express the profit, find the value of quantity that maximizes the profit, find the quantities at which the firm breaks even, and let's move to some definitions. Those quantities that I'm going to define, we will be using them when solving questions. So the first quantity, that is the price. And we use the symbol P to denote the price. And this price is defined as the amount of money the consumers pay to buy the goods. The next quantity is the demand quantity. And we come across this quantity before, quantity demanded, which is the amount of goods demanded by consumers. And the total revenue, we use the symbol TR for that. So it's the amount of money the firm receives from the sale of goods. So TR equals P multiplied by Q. So if we multiply the price of the quantity by the quantity of goods, we will get the total revenue, the amount of money that the salesman will receive when he sells goods to the consumers. Next quantity is fixed cost. We will use the symbol FC for the fixed cost, which is the amount of money that the firm has to spend to produce the goods, and this quantity does not depend on the amount of quantity produced. Examples on this kind of cost, which we call it fixed cost, like electricity and water bills, buildings rental. Let's say the producer is renting land or place, so he has to pay for the rental of this building every month, whether he produces small amount of a quantity or whether he produces huge amount of a quantity. So it does not depend on the amount of a quantity produced. Other examples like the monthly worker salaries. Now this producer has some workers working with him, so he has to pay salaries to them. So the salaries don't depend on the amount of a quantity produced. So such cost, we call it the fixed cost. It means it's a fixed amount that the company or the firm or the producer has to pay every month. Another type of cost is the variable cost. The variable cost here is the amount of money that the firm has to spend to produce the goods, and it does depend on a Q. So this cost, which we call variable cost, depends on the amount of a quantity that the firm produces. Normally, it's directly related to the amount of goods produced. If the amount of goods produced is higher, the variable cost will be higher. If the amount of goods is less, then the variable cost is less. So we have two types of cost, fixed cost and variable cost, FC and VC. So the total cost here will be the addition of these two costs. So the total revenue here, which will be the total amount of money that the firm has to spend to produce the goods, is given by this equation TC equals FC plus VC multiplied by Q. This is the fixed cost, FC, and this is the variable cost multiplied by Q, because it depends on Q. So we have to multiply the variable cost, because this will be given as amount of money per good for each unit. So if we multiply by the number of units, Q, we will get the total variable cost. So this is the fixed cost, FC, and this is the total variable cost, which is VC multiplied by Q. So the addition of these two types of cost will give us the total cost. Now, another quantity, which is profit, and we will use this symbol, the Greek alphabetic, pi, Pi, we read it pi. And this is defined as the difference between the total revenue and the total cost. So the profit of the company can be calculated using this relation, TR minus TC. So total profit minus total cost will give us the profit. It's very simple. I mean, total revenue is the input, total cost is the output. So the input minus the output will give us the profit. Now, there's a quantity or there's a situation where the profit is zero. So when the firm does not receive any profit, i.e. the profit is zero, this situation is called break-even. Break-even means the company does not make profit. The company does not lose money as well. So the profit equals zero. So at this stage, when the input equals the output, means the total revenue equals to the total cost, i.e. the profit is zero. This situation, we call it break-even situation. Let's have an example to learn more. So given the demand function P equals minus 2Q plus 100, express TR, the total profit, as a function of Q, then determine the value of TR when Q equals to 10. We come across such a function earlier when we talked about supply and demand function, and we have seen this type of function, which we said this function is a decreasing function because here the slope of the function is minus quantity. So P equals minus 2Q plus 100 is the demand function. Now we need to write an expression for the total revenue, TR, as a function of a Q. And after that, we need to determine the value of the total revenue when Q equals 10. Well, to solve this equation, we have to refer back to the definition of total revenue. We said the total revenue is equivalent to P multiplied by Q. See, Q is the quantity produced, and P is the price of each quantity. So if you multiply the price of each quantity by the number of quantities, we will get all or the total revenue. So if we multiply this function P by Q, we will get the total revenue as a function of Q. Let's see. So the total revenue here becomes minus 2Q plus 100. This is P, the demand function P, multiplied by Q. So if you multiply out this bracket, you will get minus 2Q squared, because minus 2Q times Q is minus 2Q squared, plus 100 multiplied by Q is 100Q. So this is the expression for the total revenue as a function of Q. TR equals minus 2Q squared plus 100Q. Now we need to determine this total revenue when Q equals 10, means when the quantity demanded Q is 10. So what we need to do is just substitute this Q by 10. So we will have TR equals minus 2 multiplied by 10 squared plus 100 multiplied by 10 we will get minus 200 plus 1,000, that is 800. So the total revenue now is 800. Okay. Let's have another example. If fixed cost FC are 4, variable cost per unit are 2. See here, variable cost will be given per unit, means for each unit, for each good, the variable cost is 2. Express the total cost, TC, as a function of Q, then determine the value of TC when Q equals to 5. So this is the solution. We have to use this formula. The total cost equals the fixed cost plus the variable cost multiplied by Q. Always we multiply the variable cost by Q. Again, because VC is given by the cost per quantity for each quantity. So if we multiply by the number of quantities here, we will get the total variable cost. So what we need to do now, we have to substitute FC by 4, and VC here we have to substitute it by 2, because the variable cost per quantity is 2. So we have to replace VC by 2 and multiply it by Q. So 4 for FC, for VC is 2, and we multiply it by Q, we will get this expression for the total cost, 4 plus 2Q. See, this is the total cost as a function of Q. It depends on a Q. Okay. Now, when Q equals to 5, what will be the total cost? So when Q equals 5, we have to substitute this Q by 5. So it will be 4 plus 2 times 5. That is 4 plus 10, which is 14. So this is the total cost. Okay. Now let's see example number 3. If fixed costs FC are 4, variable cost per unit are 1, and the demand function is P equals minus 2Q plus 10. Part A of the question, express the total revenue TR as a function of a Q. Part B, express the total cost TC as a function of a Q. Part C, express the profit pi as a function of Q. Part D, for what values of Q does the firm break even? And last part E, what is the maximum profit and the corresponding value of Q? So let's solve all these parts of the question one by one. So I will start with part A. We are going to express the total revenue TR as a function of Q. It means that we are going to write an expression for TR in terms of Q. We have to remember that the fixed cost is 4, the variable cost per unit is 1, and this is the demand function. Again, we said the total revenue is P multiplied by Q. So this is the solution of the first part. TR equals P multiplied by Q. So we have to multiply the demand function by Q. So we will have minus 2Q plus 10 multiplied by Q, which is minus 2Q squared plus 10Q. Okay. And for part B, that is, we need to find an expression for the total cost. We said the total cost is the fixed cost plus the variable cost multiplied by Q. And then we have to replace FC, the fixed cost, by 4 and the variable cost by 1. Then we will get 4 plus 1 times Q, that is 4 plus Q. So this is the expression for the total cost, and this is the expression for the total revenue. Now, next, we need to find an expression for the profit. We said the profit is the difference between the total revenue and the total cost. So if we substitute the total revenue from here and the total cost from here, what we will get is minus 2Q squared plus 10Q. See, this is the first two terms are the total revenue, and the last two terms here is the total cost. So if we multiply out this bracket, and we collect the like terms, we will get minus 2q squared plus 10q minus 4 minus q. Be very careful of this negative sign because many students will do the mistake here. They don't use the bracket, and then when they substitute TC, they will write minus q plus minus 4 plus q. This is a common mistake among the students. So that's why you have to use the brackets in front of these or to include the total cost. So it will be 4 plus q in a bracket. So when you multiply out the bracket, it will be minus 4 minus q. Then we have 10q and minus q. This is 9q. So here we will have minus 2q squared plus 9q minus 9. So this expression is for the profit. You can see here, this is a quadratic equation, right? This is a quadratic function, minus 2q squared plus 9q minus 4. It's quite similar to what we learned in section 2.1 for the quadratic function. But in that section, we use the symbols x and y. Here we are using q and pi. And if you remember, in one of the examples we solved last week, we used these symbols q and pi. So here the expression of the profit pi as a function of the q is a quadratic function. Okay, so in part A, we found the total revenue expression. In part B, we found the total cost expression. And in part C, we found the profit expression, which is a quadratic function. Now, in part D, we need to find the point where the firm breaks even. And as we said at the beginning of this lesson, the firm breaks even means the profit equals 0. So when the profit equals 0, this situation is called break even. So we need to find now the value of a q, the value of a quantity at which pi equals 0. So we have to solve this quadratic equation. When the profit equals 0 means this minus 2q squared plus 9q minus 4 equals 0. So we have to solve this quadratic equation to get the value of a q at which the profit pi equals 0. We did learn in the previous section how to solve such equation. We said we use two methods, either factors or formula. For this type of equation, it will be quite difficult for you to factorize it because the coefficient of q is not 1. So I would like to suggest you use the formula that we learned. So we will solve this equation by using the formula. And the steps to do so are as the following. First, we write down the coefficients, the values of the coefficients. So referring to this quadratic equation, we have a equals minus 2, and we have b equals 9, and we have c equals minus 4. So this is the first step normally we do when we solve the quadratic equation. The next step is we determine delta. If you remember delta, which we call it the discriminant of the quadratic equation, which is defined as minus b squared minus 4ac. We just need to substitute b by 9, a by minus 2, and c by minus 4. So if we do this substitution, we will get delta equals 49. Then we need to find q1. Remember, in the previous section, we used to say x1 and x2 because the symbols used there for the variable is x. Now the variable used is q. So instead of x, we will be using q. So here q1 is defined as minus b minus delta, or square root of delta divided by 2a. So if we substitute b by 9 and delta by 49 and a by minus 2 and do our calculation, we will get a q1 equals to 4. And then for q2, we use almost the same formula, except that instead of minus, we use plus. And if we do our calculation, we will get 0.5 for Q2. So the solution of this quadratic equation are Q1 equals 4 or Q2 equals 0.5. So at these two values of Q, the profit is 0. So we have to say here the firm breaks even when Q equals 0.5 or when Q equals 4. So at two values of Q, the firm breaks even. So this is the solution of part D. Let's see part E. Part E asking us to find the maximum profit and the corresponding value of Q. If you remember, when we talked about the quadratic function and the graph of the quadratic function, we said the graph of the function either concaves up or concave down. And in each case, there is a point where, sometimes we call it the turning point, where the graph of the function has a maximum point or a minimum point. So it depends on the coefficient of x squared. Here we have a similar situation where the quadratic function of the profit has a maximum point. So this is the quadratic function of the profit again. The value of a here is -2, which is less than 0. So the graph of this function concaves down. So since a is less than 0, then the quadratic function concaves down and has a maximum point. Now we need to find the coordinates of this maximum point. It means that we need to find the value of q and pi at the maximum point. So we refer to q as qm at the maximum point. And to find it, we have to use the formula which we learned in the previous section. If you remember this formula, qm equals minus b over 2a. So substituting b by 9 and a by -2, we will get a value of a qm that is 2.25. So this is the value of a q at the maximum point. If we take this value of a q and plug it here, then we can calculate the value of the profit pi at the maximum point. We will call it pi m. So substituting q here by qm, which is 2.25, we will get the value of the maximum profit, which is 6.125. So this, the last value here, 6.125, is the maximum profit the firm does, which is at q equals 2.25. So for this firm to have a maximum profit, it has to produce a quantity equivalent to 2.225, and the maximum profit will be 6.125. So I hope the solution is clear. Now, to emphasize on this topic, there are some exercises, and I want you to solve those exercises, and we can discuss those exercises during the class. So very quickly, I'll just go through these exercises. So exercise 1, here we have the demand function, and we need to find the price P when Q equals 10. We need to find the total revenue when Q equals 10. And then in part C, if the fixed costs are 100 and variable costs are 5 per unit, we need to find the total cost TC when Q equals 10. So try to solve this equation. And also you need to find the profit when Q equals 10. Now exercise number 2, if the fixed cost FC are 100, variable cost per good are Q plus 6, and the demand function is P equals minus Q plus 60, we need first to express the total revenue TR as a function of a Q. We need to express the total cost TC as a function of a Q, and we need to express the profit pi as a function of Q. And then for what values of Q does the firm break even? And then what is the maximum profit and the corresponding value of Q? This is exercise number 2. Thank you. That's it from me today, and we will see you during the class. Bye-bye. Assalamu alaikum.